There are times in which we have what's known as a proportion or a ratio that we want to develop a confidence interval for. Now, it's most commonly used when we are trying to look at a ratio of, say, approval ratings or the percentage of people who said yes to a certain question on a survey, and we see this on the news quite often. So we're going to use that as an example. We hear constantly the president's approval rating is 55% with a plus or minus 3% margin of error. So let's take a look at what this means, and let's try and determine how we create these confidence interval, and we'll also take a closer look at that margin of error. So if we interviewed 100 people, we would have 55 approve and 45 disapprove. And so we're going to use this as our sample proportion, 0.55. The formulas are given on the right. Our confidence interval is going to be this p hat, which is this estimate of the proportion of approve or success, or whatever it is the variable of interest is, plus or minus our z multiple, with alpha being the confidence level, multiplied by the standard error of p hat, which is given by this formula up here. So the first thing we need to do is calculate the standard error of the proportion. And that's going to be given by this formula, which is just p hat, which is the 0.55, times 1 minus p hat, which will be 0.45, divided by the number of observations, which is 100, and we take the square root of that. And as you can see, when we doing that formula up here, square root of C10 times 1 minus C10 divided by C9 will give us the formula that we want. And the result is 0.0497. Now to calculate our z multiple, we've done that over here, and the z multiple is 1.96 because we're going to be taking the norm.s.inv, and again, remember, since it's 95%, we're looking at the 5% under the tail, which is going to be given by the 0.975 on the norm INV, the standard normal inverse function, which gives us the area under that curve. It tells us the point at which 0.975 of the curve is underneath. So we get 1.96. We carry that over to here, and we end up with our 1.96, and we have all the pieces that we need now to calculate the confidence interval. We'll plug in the p hat, we'll do minus the z multiple times the standard error, and we end up with 0.4525. It's given by this. Our upper limit will be the same thing, only with a plus, and it gives us 0.64. So as you can see, that's a pretty wide range, and our margin of error becomes 9.8%, or 0.098. And that's because we're taking the C12 multiple times C11, which is the standard error. So this portion over here on the right is what will give us the margin of error. It tells us the margin of error. But let's see what happens as we increase the number of people. So we're going to take basically the same set of values, and we're going to have now 500 people. And so that will give us 275 approve and 225 disapprove. We keep our sample size at 500. Our sample proportion is 0.55. Now we'll calculate our standard error of the proportion. Again, using the square root formula, we end up with 0.022. So you can see that the number has changed and the standard error has dropped. We bring our z multiple, that doesn't change. And our lower limit now, as you can see, becomes the same formula, only using the new values. It's now gone as the lower limit of 0.50 to the upper limit of 0.59. So you can see that the margin of error has significantly reduced, down from 9.8% to 4.4%. So now assume that we even double that and we end up with 1,000 people. We should see this number of 4.4 really reduce in terms of our margin of error. So we change our sample size to 1,000. We do our sample proportion of 0.55. Now we'll recalculate the standard error of the proportion. And you can see that from here it went from 0.02, now it's down to 0.015. We will carry our z multiple, which is 1.96. And we will calculate the lower limit as 0.519 and our upper limit as 0.58. And so that reduces the margin error from 4.4% to 3.1%. And so you can see that as we increase the number of people, we end up reducing our margin of error, which is what we had expected from previous modules. And so when you hear, for example, going back up to the top, President's approval rating is 55% with a plus or minus 3% margin of error, you will know that this 3% margin of error is going to constitute to the fact that they've interviewed approximately 1,000 people.